Hello, everyone. Our next speaker is Dr. Lawrence Brass. Dr. Brass is the director of the MD-PhD program at the Perelman School of Medicine, which is currently the largest in the United States. He is also an MD-PhD trained physician scientist, a professor of medicine taking care of patients with bleeding and blood clotting disorders, and an NIH-funded investigator doing research to better understand why such disorders occur. Dr. Brass has been active at the national level in the development of training programs for physician scientists, has served as the president of the National Association of MD-PhD Programs, chair of the AAMC Grade Section on MD-PhD training, and was a member of the NIH Physician Scientist Workforce Advisory Group in 2013. Please welcome Dr. Brass as he discusses the topic ins and outs of the MD-PhD career path and talks about what MD-PhD programs look like and other ways to become a physician scientist. During our opening statement, I saw that many people were interested in this presentation, so please remember to use the Q&A chat to ask questions and also upvote any questions that you like. So at this point, I will stop sharing and Dr. Brass can start his presentation.
Thank you, Alejandra, for that introduction. I am trying to make sure that my screen is shared and that the slides are showing. Can you confirm that for me?
Yes, we can see the slides.
Great. Good morning, everyone. I wish I could see each and every one of you, but all I can see is my own monitor. But it's nice to have you join us for this part of the conference this morning. I know that many of you who are attending the conference are doing it because you're thinking about applying to medical school, or you may be in the process of doing that now. This particular session is intended to help those of you who are contemplating not only becoming physicians, but physician scientists, that is, an investigator. And I'll talk about what that means in just a moment. A lot of what I'm going to be talking about is the ins and outs of applying to MD-PhD programs and what the programs are built like and how they're supposed to help you. I'm going to do that in a generic sense rather than talking mainly about the program that I direct at the University of Pennsylvania. But toward the end, I'll toss in some information about Penn's program as well, because a lot of us are very proud of it. This is mostly about figuring out for yourself the answer to the question that shows on this first slide. Becoming a physician scientist, is it the right thing for you? It was the right thing for all of the fine folks that are in this particular picture, all of whom are either faculty members, there's one of them in the picture, or are MD-PhD students who are working their way through the program, completing both medical school and graduate school. In this particular case, this group of students all happen to be in the medical anthropology program at Penn. So unlike me, I'm a laboratory-based scientist. They're doing their research and their scholarly work in anthropology, and we can talk about that as well. And if there are any social scientists on this call who would like to know more about that, put your questions into the chat channel, and I'll try to answer them for you a little bit later. This slide and some of the other ones has my name on it and my email address. I hear with a fair degree of regularity from lots of undergraduates and recent college graduates who are interested in applying to MD-PhD programs, and I'm happy to hear from you, and I'll do my best to keep up with all of you and answer questions that are sent to me by email after this is over with today. Or I may ask some of the current students at Penn to help you out as well. So a good place to start when you're trying to answer the question about becoming a physician scientist is, what is a physician scientist? And some of you may know that, and some of you may not be totally convinced about what it all means. So let's kind of walk our way through this by way of a background. So a physician scientist could be a man, could be a woman, who are trained as being both a physician and an investigator. And I'm using the word investigator here just because, although classically, most of the scientists who were trained through MD-PhD programs were laboratory-based scientists, that's no longer the case. And so MD-PhD students include lots of people who are social scientists, and I mentioned the anthropologists on the first slide, but also people who are studying bioengineering for the PhD, or history, or economics, who are doing really these days a whole range of things. Many MD-PhD programs will offer a variety of different PhDs that they're associated with. You just have to look and see what they're doing and what they have to offer and compare that to your interests. Second, most of us who are physician scientists, I count myself as one, spend most of our professional time doing research and applying research. And what that means is that we're not only taking care of patients, but we're thinking about the problems that the patients have in terms of, what are the underlying mechanisms and what can be done to come up with new treatments to approach what's wrong with them and try to make them better. And I'll come back to that in just a moment too. Third point, many of us also take care of patients and do research that is tied to human biology and human disease, often studying the diseases found in our patients. So sometimes when people approach me to talk about, MD-PhD program graduates and what it is that they're doing at the time, they are asking the question from a perspective that turns out to not be entirely accurate. They say to me, why should I go to medical school, learn how to be a doctor, and then spend all my time doing research in a laboratory? And my usual reply to that question is, well, there are some of us who do just that and are grateful for the fact that we've learned much more about human biology and human disease and going to medical school than we ever would have by going to graduate school alone. In fact, the data show that most graduates of MD-PhD programs are doing both, taking care of patients and doing research, and trying to merge the two together as much as possible. Come back to that point in a little bit too. And finally, where do we work? So it turns out that the data show that most graduates of MD-PhD programs end up as faculty members in academia. And I'll show you the breakdown on that after a bit. Others work at places like the NIH or other research institutes. There's some graduates of MD-PhD programs who are working for government agencies like the FDA and the CDC. And then there are a bunch of graduates who end up doing interesting jobs in the biotech and pharmaceutical industries. Not infrequently, running large programs within biotech and pharma, or even running companies. And I'll show you some examples of that as well if we have sufficient time today. All right, so what is a physician scientist? Let's try another way of thinking about it as well. And my favorite way of talking about what a physician scientist is to point out that we become chimeras who blend together clinical medicine with the discovery and application of new knowledge. So if you look here in this cartoon in the lower left, there are two overlapping circles, physician and scientist. But another way to think about it is that we are chimeras, that we blend things together. Many years ago, when I was coming out of college and thinking about applying to one of the earliest MD-PhD programs, so this was a while ago when there weren't very many programs, I went around and asked for advice from people. There weren't many MD-PhD program students and there weren't many MD-PhD program graduates at that point. And some of the comments that I received, including the ones from my undergraduate PI, I was in a department of chemistry, was, being a physician full-time is a full-time job. Being a scientist is another full-time job. How can you possibly do both? And how can you blend together everything in a meaningful way without just kind of feeling inadequate as a physician and inadequate as a scientist? Well, I know that argument against becoming a physician scientist still exists because I regularly hear it repeated from undergraduates who've been advised by people who are, just one or the other, just a physician or a scientist. And it's left them somewhat confused as a result. But I really point out that the best way of thinking about it is that a physician scientist is a unique career path. It blends together aspects of being a physician and aspects of being a scientist. In my opinion, it blends together the best parts of each of those into something that is unique and different from either one alone. It's a chance to have a very different perspective on the medical problems that we see in our patients and a very different perspective on the research that we want to do when we make the choices of what we're going to work on and what we're going to do with the information as we discover it. So remember this image on the right, the statue of the chimera, pretty fierce looking, a blend of, in this case, several different kinds of animals. That's what you're trying to do when you become a physician scientist. Be somebody who's a unique blend of a couple of different, really important, really meaningful careers. Turns out that we do a lot of things. And I showed this here as a triangle just because I picked three of them that people often talk about. We see patients and take care of them. We do research and we do teaching, a blend of three different things. In fact, When I was in a combined degree program, I used to hear from senior faculty that the goal was to become a triple threat. That is somebody who could both take care of patients and do research and spend time teaching as well and be good at all of them. I'm not sure that I really like the term threat. I don't feel like I'm threatening anybody when I go about my business and do my job. But it's a good way of thinking about things, that you combine lots of different things together and balance them in different ways according to what you're doing at any given time and where you are in your career and how you want to do it. So a good example of that, I think, is the morning that I've spent for the last several hours since I was up and around, and the things that I've done this morning. So I spent part of the morning talking with the folks who are on the clinical team that I'm part of this month, discussing a couple of patients who have problems with their platelet count or problems with a potential bleeding problem that could interfere with their ability to have a surgical procedure later today. I spent part of the day in a video conference with a number of members of my own research team talking about a project that we're running using machine language to assess data on COVID-19 patients to try to find things that are strong predictors of doing well or doing less well in people who are infected with SARS-CoV-2. Some of those problems are blood clotting problems, and I'm particularly interested in those because as a hematologist, that's what I deal with on a clinical basis all the time. And part of my morning was spent working with other members of my research team, talking about some studies that we're doing currently in mouse models, trying to understand basic mechanisms of why blood clots happen and ultimately how they can be prevented from happening in the patients that I take care of. So that's a morning that was spent with research and patient care and with teaching, all blended together. And I am in no way unique in that regard. That kind of blend, that kind of chimeric approach to things is exactly what scientists get to do on a regular basis, and is one of the most appealing things about the job for me. So there are joys as well as challenges to being a physician scientist in the 21st century. And I want to illustrate that point with, with a couple of quick anecdotes about several of my colleagues at Penn. So here on the lower left is a picture of Carl June, who some of you may have heard of. He's a physician scientist working at the University of Pennsylvania. And Carl is most famous at the moment for being one of the inventors of CAR T-cell therapy. And the patient that's just to his right is a little girl who had refractory leukemia, who had gone through a number of the standard procedures that we use for curing leukemia in adults and children, and had unfortunately relapsed and was failing and was likely going to die. What Carl succeeded in doing was taking the patient's own T cells, that is T lymphocytes, re-engineering them ex vivo into cells that would attack her particular type of leukemia, reinfusing them back into her, where they took up housekeeping and did the job that he wanted them to do, killing her leukemia cells. This picture was from 2012. She was already doing well by then. Now it's 2020. She's older. She's doing fine, the last I heard. Really exciting stuff. Translation of basic laboratory findings on mechanism into things that can be done in the clinical space. Here's another example. Two of my colleagues, Kathy High and Jean Bennett, both of whom have been working on gene therapy for a number of years, and both of whom have had a great deal of success in developing gene therapy approaches as ways to cure people who have hemophilia B and some forms of congenital blindness. So Kathy High is, like me, a hematologist interested in bleeding disorders. Hemophilia B is a severe life-threatening bleeding disorder due to a specific mutation within a particular gene called factor IX, one of the blood clotting proteins floating in the blood. And what Kathy succeeded in doing was making a genetic change that would correct the defect that was present in the patient with abnormal factor IX, so that those patients have now been, we hope, effectively cured by sustaining a sufficient level of normal factor IX to keep them from having bleeding problems. She used that information to do a biotech startup, which has done very, very well, and she continues to be interested in gene therapy. Jean Bennett, on the right side of this particular photo, is an ophthalmologist, an MD-PhD, interested in doing gene therapy in the eye to fix congenital disorders that are due to genetic defects in particular proteins that are important for signal transduction in the eye, that is the conversion of light images into brain signals so that you can see. And she's had great success doing that as well. So all physicians, all scientists, all physician scientists and all emblematic of what can be done with the appropriate training to be a physician scientist and the commitment to discover new things and make people better. What could be more exciting than doing that? What could possibly be better than doing that? Well, I don't want to leave this slide with and have you have the feeling that all the interesting problems have been solved, because here we are in 2020 in the middle of a pandemic from a coronavirus, where patients or people are getting infected and developing COVID-19, a problem that is still prevalent to a far greater degree than any of us thought would be back in December when the outbreak first began. So COVID-19 still presents an array of problems, both at the mechanistic level and at the therapeutic level, that haven't been overcome. So the work still needs to be done, but this is just one example of that. The real question, I think, is not whether physician scientists will be actively engaged in the process of figuring out the answers to these questions. They already are. But the question is, who will be the ones who make the biggest differences? I hope that everybody who's listening to this seminar and thinks, gee, I would love to be able to do that kind of work. I hope that by the time you get to the point where you're leading your own research team, that COVID-19 will be something from the history books. But there'll be other problems coming along, because they do on a regular basis. Well-known problems and problems that haven't emerged yet, all needing the attention of people who are trained as both physicians and scientists. So let's say I've now sold you on the notion that it's really cool to be a physician scientist, because it's really cool to be a physician scientist, and that you'd like to do that. You know, how do you go about doing that training, and what's involved? And is it really true that it takes forever, and that you know, that you'll never get there even if you start tomorrow? So it's not true that it takes forever to get there, and you will get there if you start tomorrow. But it's a good idea to understand what the path ahead is all about. So let me see if I can help you with that with a couple of cartoons. So the path to becoming a physician scientist, almost by definition, requires both clinical and research training. And when I say clinical training, I'm speaking broadly as in going to medical school. If you're going to be a physician, you have to go to medical school, whether it's allopathic or osteopathic. You need that training and that knowledge base of human biology and human disease. Research training can come in a variety of different forms. And what I'll say in summary, and then I'll show you in a little more detail, is that if you're going to be a physician scientist, you need to be trained to be a scientist, because medical school doesn't teach you that. Medical school is really good at teaching all of us how to become great doctors. It doesn't teach how to be a scientist. So one way or another, you need that additional training, and there are different ways to do that. I'm going to illustrate that point with 3 different paths to doing it, one of which is MD-PhD programs, but I want all of you to realize that it's not the only path, and what the pros and cons of each of them are. So, path to becoming a physician scientist. Step 1 is sign up to go to medical school. And medical education these days can take 4 years if you go straight through. In some places, they've gotten it down to 3 years, but that's usually to train clinicians. So medical school, let's call it 4 years just for the sake of this conversation. An opportunity to extend medical school a little bit and spend a year doing research. Lots of people will do that usually in a year out between the 3rd and 4th years of medical school. And there are a variety of programs that support doing that I don't have time to talk about today. Instead, I'm going to talk mainly about this thing called an MD-PhD program, a program that puts everybody through not only medical school, but graduate school. You know, graduate school won't teach you how to be a good doctor, but graduate school can teach you how to be a really good scientist or investigator in whatever field that you're most interested in marrying to being a physician. So average at this point nationally is 8 years to do an MD-PhD program. The range typically is in the 7 to 9 year range. So 7 to 9 years, depending upon, however long it takes you, is clearly longer than just doing an MD. So there must be some value in doing that. And if there isn't, then why spend the extra time? Well, the value, of course, is getting additional rigorous training to be a scientist. And again, that's exactly what graduate school is all about. So graduate school is not just about having a PhD after your name. Graduate school is all about learning to think like a scientist, which is somewhat different than thinking as a physician, and learning how to identify interesting problems and break them down in ways that can be tackled so that the problems can be solved. At least that's graduate school in a nutshell, no matter what field of interest you have. If you go to medical school, after you finish medical school, you're going to have to do a couple of things, and that's what's shown in yellow up at the top. You have to do postgraduate education, meaning after medical school, where you finish up your clinical training. That can be called an internship, or more commonly nowadays, a residency, and research training as a postdoctoral fellow of one stripe or another. And if you have been to medical school but haven't been to graduate school, that research training is really, really important because you need to learn how to do it. Being a good and effective investigator, a good and effective scientist, requires training just as being a good and effective physician does. So you have to get that training. If you just go to medical school and don't go to graduate school, you're going to have to pick it up along the way after you finish your clinical training by doing a postdoc. So let's say the total training time at that point begins at the beginning of medical school and ends when you finish up a residency, a postdoc, and all your advanced clinical training. If you do the MD plus approach, taking 5 years to go through medical school with a year out in research, that year out will help you really get your feet in the ground in terms of research. It won't likely give you the formal training that all of us get by going to graduate school, so that when you finish medical school, have an MD, and launch yourself into postgraduate training, you'll still not only need to do residency to finish your clinical training, but you'll need to do some additional training at the postdoctoral level to bring you up to speed on all the skills that are necessary to be a successful scientist in the United States today. That includes learning how to give good talks, how to read the literature properly, how to write grant applications, how to do good research, and how to organize and lead a team of investigators that are necessary for doing work these days. If you do an MD-PhD program, you're going to have to do some of that as well. So MD-PhD students who take 8 years on the average to finish both degrees still have to do a residency if they want to finish up their clinical training, and then they get back into the research setting again. But typically, they don't take as long to do all of that and then get a job at the end of all of this as a physician scientist as somebody who's just started by doing medical school. In other words, what I'm trying to explain in a hopefully not too subtle way is that the total training time is all of the things from MD to PhD to postgraduate work before you get that first job as a physician scientist. And the length of time it will take you to do that, the data show, is about the same whether you skip going to graduate school in the hopes that you'll get there faster or not. The data suggests that that isn't the case. So I always try to make a strong point to anybody who's contemplating MD-PhD programs but worried about the time that's required by pointing out that if you want to be a physician scientist, you're going to need to train as both a physician and a scientist. And it's going to take you a while to get all that training, and you won't save any time by avoiding going to graduate school in the hopes that somehow you'll soak it all up by osmosis. Let's focus mainly on MD-PhD programs for just a little bit. Again, I want to talk in a generic sense, not about Penn's program in particular, but a lot of what I'm going to say applies to Penn as well as to other places as well. So MD-PhD curricula, back when I was an MD-PhD program student, was basically you did 2 normal years of medical school, skipped out to the side for a while, did a normal course through graduate school, skipped back to medical school, and finished up in the last 2 years of medical school. And there was no attempt in any meaningful way to connect medical school and graduate education, that is to turn us into chimeric physician scientists. But that approach to things has really gone by the wayside. And what we all try to do now in our programs in a variety of different ways is to blend things together. So typically the first couple of years are mostly spent in medical school, but all of us do some things with graduate school training as well during those first couple of years. Some graduate school coursework and some research time. Some efforts to identify who's going to be your thesis advisor when you hit graduate school and to get you up and rolling as quickly as possible in your thesis research. In approximately year 3 of the program, everybody segues from medical school over into graduate school as being their predominant time, really focuses in on doing their research for their thesis. But also because a lot of the programs now, especially at Penn, give serious clinical training during the first 2 years of medical school, try to leverage that training by having some meaningful clinical experiences during graduate school while also spending most of your time doing research. In other words, it's an opportunity to learn how to blend together your time as both a physician and a scientist. Exactly what you'd want to do with somebody who's training to do that for the rest of their careers. After you finish up graduate school, you head back to medical school to finish up your clinical requirements for graduation. Lots of students will do some more research and other activities that promote their ability to be a physician scientist, and then off they go 95+% of people who graduate from MD-PhD programs in the United States then go on and do residency so they can finish up their clinical training and be clinical physicians within an academic medical center or other setting where they're taking care of patients so that they can see firsthand the medical problems that they're trying to find new ways to understand and cure. I should mention, which is why I put it in bold red here, that one of the nice things about being an MD-PhD student, one of the things that helped me back in the dark ages and can help all modern MD-PhD students as well, is that most MD-PhD programs provide a fully funded fellowship that covers not only the cost of going to graduate school, but also the very high cost of going to medical school as well. And when I say the cost, that means not only tuition and fees, but also a stipend to live on. And those stipends these days vary in the 30,000 range to as high as $40,000 per year per student. So running an MD-PhD program means having to shell out a lot of money at all medical centers, but it also makes it possible for future physician scientists to go through all of this training and not emerge with a heavy debt burden that might affect their decision on what they're going to do with their careers and whether they're going to stick at being a physician scientist. So that's a good thing to know about. What else is included in an MD-PhD program? I just popped a bunch of things up here in a slide that I used to illustrate what we try to do at Penn. The point of this slide, just to reduce it down to its essentials, is medical school plus graduate school, teaching you how to merge the two of them together. And in addition, lots of activities that bring together physician scientist trainees with physician scientists to help them learn some of the skills and some of the approaches and the kind of resilience that's needed to be a successful physician scientist. Definitely more than an admissions committee and a graduation party. All right, so let's say you decide to do all of this and you launch yourself through an MD-PhD program and you work your way along and you finish up your postgraduate training as well. And eventually you'd like to get a job. And fortunately, history shows that MD-PhD program graduates are very successful in getting jobs. You know, where are you likely to end up for that job? Well, that's a great question because you ought to know that before you launch into a career path. What are the range of possibilities for what you can do later on? So this particular pie chart is just one of a lot of similar pie charts that you can find in the literature. This happens to be from the National MD-PhD Program Outcome Study that a few of us did in a collaboration with the AAMC, and that came out in a report in 2018. And I mention that because you can find it on the web and you can read it if you want. It's got a nice summary at the beginning. After that, it's lots and lots of pages with lots and lots of figures and data. And if you're a data nerd the way I am, you might enjoy reading all that. But let me give you just at least this one piece of information. So we chased down a lot of graduates of MD-PhD program, and there are many thousands of them now, and said to them, have you completed all of your training, that is residencies and postdocs and so on? If you have, and you have a job, what kind of place are you working? What's your current workplace? And the data that came back said that about 2/3 of the graduates of MD-PhD programs are faculty members at academic medical centers and universities around the country. That's a much, much, much higher percentage than of medical school graduates in general who end up as faculty at medical schools. So this is a very successful outcome in that regard, but that's still only 2/3. What about the rest? Well, some of the graduates are working at the NIH and doing very well, doing research or leading research programs there. Some are working at other federal agencies other than the NIH. Examples include, the CDC and the FDA, among others, and lots of other three-letter abbreviated federal agencies. Some were working at research institutes, places like Scripps and Rockefeller and so on. Some were in the biotech and pharmaceutical industry, as I mentioned earlier. Some are doing consulting work and finance work. Hopefully they're making lots of money that they'll then donate to their alma mater. And some are in private practice. So let me say a word or two about those who are in private practice. We take really great care in admitting people to MD-PhD programs. And we all try really hard to make sure that the people who are coming in are committed to long-term to careers as both physicians and scientists. But the reality is that some people who make that decision when they are 21 years old or 22 years old, decide along the way that clinical medicine is really what they want to spend their time doing, and they want to do it out in the community. So those graduates end up in the slice of this pie called private practice. We love all of our graduates, but that's not the goal of an MD-PhD program. You don't need a PhD in molecular biology or really anything else to be an incredibly capable and productive private practitioner doing full-time clinical work. So that's not the goal of MD-PhD programs. And so a lot of us feel when we look at this pie chart that we're really glad that the vast majority of graduates of MD-PhD programs are doing the sorts of things that the training was intended to prepare them to do. So think about where you'd like to fall on this particular pie chart. All right, that's the generic look at MD-PhD programs. Let me spend a couple of quick slides telling you about Penn's MD-PhD program, which I hope you'll consider when you apply to MD-PhD programs. Not because I'm trying to sell the program, but because I'd like to give you at least a little bit closer look at what a real program looks like and what real MD-PhD students look like. So here is the entire Penn MD-PhD program when we got together, not this past summer, but a year ago in August 2019, when we usually have a one-day retreat for the entire MD-PhD program. Last year, we could do it in real life outside. This year, we had to do it indoors and virtually, but we did it anyway. But here's the picture of everybody who was in the program at that time. Now, if you're reading the small print, you can see that Penn is one of actually a unique program that not only trains MD-PhD students for their future careers, but also veterinary students, VMD-PhD students. Penn's vet school is right down the block. So we're really fortunate that we have that type of heterogeneity with a large number of MD-PhD students, currently the largest number in the country, and then a smaller cohort of VMD-PhD students. So if you're on this call, but know, because you're interested in medical school, but know somebody who's interested in becoming a veterinarian and a scientist, tell them to consider places like Penn where you can do both. We had a large entering class that just started a couple of weeks ago with 36 men and women who joined the program. That's a lot in 1 year. The reason why we had so many was because lots of people who applied to us this year that we liked decided they wanted to be with us in Philadelphia. So we had an especially large entering class. We have over 600 alumni to the program over the 50 years, actually more than 50 years at this point, that the program has been in existence in training physician scientists. Great crew of people. But that's sort of a zoomed out picture showing a lot of folks all at one time. What I think about is not the mass of MD-PhD students, but the individuals who are in the MD-PhD program, making sure that we're watching over them appropriately, keeping track of them and making sure that they're getting the training that they need. And here's just two groups of MD-PhD students from over the years that I've been director of Penn's program. I love it when I look at this picture and realize that, gee, these happen to be students who've graduated and think about what they're doing now. So in the upper picture, second person from the right is a young woman who worked in my lab when she was an undergraduate at Penn, became an MD-PhD student at Penn, completed a residency in internal medicine, and now is studying hematology and oncology in the same division where I'm a faculty member, and she started as a first-year fellow. She'll be back into the lab next year working on basic problems within the laboratory space. So for me, one of the satisfaction of being Penn's MD-PhD program director for over 20 years is watching people come out of college, roll into the program, do really well while they're with us, and continue to do extremely well after they leave. Penn is the home to a large medical center. When I say Penn, of course, that's an abbreviation of the University of Pennsylvania, home to Penn's MSTP, which stands for Medical Scientist Training Program. And here's a really nifty picture of the university and the medical center campus that I like to use to illustrate. I wasn't standing on a ladder at the time. This was taken from a helicopter and then passed along to me. But everything you're seeing here is part of the medical center and part of the university. So here is the medical center, also known as Penn Medicine, circled in red. All the buildings, including the new hospital building that's still under construction, will be opening next year. Here's Children's Hospital of Philadelphia, right entangled with all the rest of Penn Medicine. So Children's Hospital of Philadelphia, or CHOP, is a great place to be trained as a pediatrician and to take care of kids. And here's the rest of the university, or at least part of the rest of the university, all wrapped around it. Take-home messages, this is really one university with lots of things going on. It's a really great place to work as a result. I'm watching the time. I was going to tell you a bit about graduates of Penn MSTP program. I think I'm going to flash through this pretty quickly, other than to say that everybody you see up here is a graduate of Penn's program, having a great career doing a variety of things, including Greg Zemenza, who won the Nobel Prize in Medicine not so long ago, who's a graduate of Penn's MD-PhD program. Let me keep rolling through a little bit of information about admissions before we stop, and Alejandra and I try to answer some of your questions as they come in. So admissions, a quick overview of it, because tomorrow one of our students, Gently Soto Albrecht, is going to be talking about admission to MD-PhD programs from her perspective. But let me give you the perspective of what we're looking for as an admissions committee. This is the Penn perspective, but everything that I'm about to show you really applies to every program that I've ever taken a look at and talked to the directors of. So it's really good general approaches. So what are we looking for when you apply? And how do we approach this in an unbiased, holistic review process? All right, so first, in no particular order, is academic success. We want to make sure that you can handle the load of information that's going to be absolutely flooded in your direction in the process of going through medical school and graduate school. So we want to see that you've taken tough courses and done well of them as an undergraduate. We're going to look at your MCAT scores, and all programs do that, some to a greater degree, some to less, some that aren't looking at them in particular this year because of the coronavirus epidemic. But ultimately, MCAT scores don't predict how anybody's going to do when they grow up to be a physician scientist. But they do tell us something about you, and it's information that most medical schools currently use in making the admission decisions that we all care about when we're applying. Research experience. So MD-PhD programs are about training scientists, physician scientists, but scientists and people who want to do research. So we want to understand what you've done in the way of research before you apply. And we want to make sure that you understand what you've done in the process of doing research as an undergraduate or a postdoc student. We want to make sure that you not only know what you did, but how it fits in with the larger picture of the problems that are being tackled in whatever research setting you're working in. So really understanding not only the details of what you've done, but what it all means. We'll ask you to write to us about that, and we'll ask you to answer questions about it when you come for your interviews. We're going to look hard at your letters of recommendation, and everybody's application arrives with a stack of letters of recommendation, and they will all say that you're wonderful. So what we're looking for amidst all that information is what the folks that you did research with have to say about you, and what they say about your potential to become both a physician and a scientist, and what contributions you made to the work that you did. So those are the letters of recommendation that are most especially important. Finally, we want to make sure that you've had clinical and service experience that tells us that you really are committed to being a doctor as well as a leader and a leader of research teams and somebody who's going to be both a physician and a scientist, because all of those things are important. We're training people who are going to be leaders of teams who want to take care of patients, and we want to make sure that you've had enough experience doing both that it suggests that you not only enjoy it, but that you have the potential to be really good at it. And finally, last but not least, we want to make sure that you can tell us in writing and in person when you come for your interviews why it is that you want to have a career as a physician scientist. What does it mean to you? What is your passion for doing this? And what's really driving you to tackle a career that's challenging but wonderful? Or maybe I should say that is wonderful but challenging, because it is both. All right, so becoming a physician scientist. This is where I started at the beginning. And I hope that you understand the question that I posed for you and try to answer as we went along. Each of you who thinks about applying to MD-PhD programs really needs to sit in a quiet corner somewhere and say to yourself, well, now I know what a physician scientist is. Is that what I want to be? Does that sound exciting to me? I hope it does, because it is an exciting career. But you have to decide, is it the right thing for you? And if so, why is that? And now, hopefully, if you decide that it is important to you, you have some insight into what it is that you have to do to be successful in the process of applying. Well, that's a lot of information in 38 minutes. Based on the plan that Alejandra and I drew up when we last talked, we still have some time left. And the hope is that while I've been jabbering away, that some of you will have posted questions on the chat channel, and that Alejandra and I can try to raise and answer some of those. So Alejandra, would you like me to stop sharing my screen in order to do that?
Yes, please stop sharing, and I will put us on gallery mode so that students can see both of us. So yeah, thank you so much. I think your presentation was really amazing. You were able to answer a lot of the questions that our students have about how to know if this program is something that they want to pursue and what it looks like, and also specific details about programs and the program at Penn, and what schools look like for students when they are selecting them to attend their school. So I have some questions from the audience and also from one of our panelists. So I'll start with the panelists' questions because they're not on the Q&A chat. So the first question is, do you typically go straight into research training when you enter an MD-PhD program? Or is the order of doing research training and medical school flexible?
Yeah, so that's a great question. Let me start with the last part of that about flexibility. So MD-PhD programs do the best they can to be as flexible as they possibly can within the constraints that are dictated by, that you have to do medical school in a particular order and you have to do graduate school in a particular order. For most people, the vast majority of people, it means starting off predominantly in medical school and then continuing on into graduate school before finishing up medical school. But most places, as I mentioned, try to blend all that together as much as possible. And that means starting research when you first arrive, starting some graduate courses, and certainly building a relationship with the graduate program that you're going to be in, starting from day one. In fact, what I tell entering MD-PhD students at Penn, and I know that a lot of my colleagues at other places do the same thing, is you're training to be a physician and scientist and learn how to blend all that together. So we want you to start off from day one doing both so that you'll learn how to do the interactions between the two of them. Let's see. And I think that covers everything in that particular question.
Yeah, I think so. Thank you so much. Let's go on to our next question from the audience. And it's a little bit long, so I'll start with the first part. Can you touch on what the lifestyle of a MD PhD looks like? What will my everyday life look like outside of work? Will I have time to spend with my family and hobbies?
So I'm not sure whether the question is what will it look like as an MD-PhD student, or what will it look like as an MD-PhD physician scientist out in their career. Why don't we start with the second one of those? All right. So the career of a physician scientist and how it feels is busy. There's no question about that. You spend a lot of years learning how to do a wide variety of things very effectively. And if you care a lot about all the things that you're doing, then the natural tendency is to spend a lot of time doing it. But the reality is that everybody needs to find ways to balance both their professional time and their non-professional time as best they can. And so MD-PhD students who become physician scientists have families, they have kids, they raise those kids. The kids end up as healthy people, and sometimes they apply to MD-PhD programs. Learning the skill of balancing a busy profession with a life is an important skill and something we talk about a lot during MD-PhD training.
Great, thank you so much. And another question from one of our panelists is, do you need to take the GRE in addition to the MCAT to apply for an MD-PhD program?
Yeah, good question. The answer, usually not. There are some occasions where a particular PhD program normally requires GREs and is not willing to accept the MCAT as a substitute. And they'll say, gee, we want to see GRE scores as well. Having said that, I'll use data from Penn as an example, where I would say 98% plus of our incoming students never take the GRE, they just take the MCAT.
Okay, perfect. Let's look for another question from the audience. I think you kind of answered this during your presentation, but it says, for an MD-PhD program, how long are the residency and postdoc? What was your MD residency in? Sorry.
Okay, so for me, I finished up an MD-PhD program, getting a PhD in biochemistry. That took me 7 years start to finish. I then did a residency in internal medicine, which took me an additional 2 years. And then I followed that by entering specialty training in hematology and oncology. So that's blood disorders and malignancies. That's normally 3 years to complete. In my case, in the case for other physician scientists, that was a year of full-time clinical training, with 2 years as a postdoc working in a lab, and then I got a job as a faculty member. So let's add all that up. That was 2 years of residency, 3 years of fellowship plus postdoc, that's 5 years, and then I was an assistant professor. That was a while ago, and that's not usually the case now. Usually now people take longer than we did back in my day to finish all that training. And the number of years can stretch to 6, 7, sometimes 8 years, and it takes a while. There's been a lot written about this, and you can read about it if you like in that national outcomes report that I described from the AAMC. Some of us think it's taking too long and are doing what we can to try to shorten that period of time. But here's the reality. When you get that first job, if you're in academia and you're an assistant professor on a tenure track, you get a big startup package to start your laboratory and hire people and to do research. Bingo, you're suddenly running your own team. You're also taking care of patients and making important decisions in their lives about their health. And you're working hard doing lots of things. We're expected to be able to do a lot. And so it's not so much of a problem that the training takes a while to get there. Although, you know, maybe it would be better if it was a little bit quicker, but that's where things are these days.
Great, that's amazing. And I also really like that you clarified during your presentation that students receive a lot of support, monetary support. So I think that it's really helpful for such long amounts of training that students need.
Yeah, thanks for pointing that out, Alondra. Let me add along those lines something that may not be completely obvious, which is that medical training and graduate training are all about first learning how to do things under close supervision, and then learning how to do them with less supervision, and then gradually being the person who's supervising other people. So along the path that leads from college to having a real job as an attending physician and scientist at a university, you go through a lot of steps where you're doing lots of things and taking increasing amounts of responsibility for them. It's not as if you're spending all your time thinking, someday I'll get to do research. Someday I'll get to take care of patients and participate in their management. You're doing that all along the way, very, very quickly.
That's awesome. Okay, I think we'll do probably our last question, and it's from the live stream. It says, for non-traditional students, considering a GPA requirement, will graduate coursework be considered more heavily than undergraduate?
Yeah, so that's a great question, because I talk to a lot of students who usually about 3/4 of the way through the conversation admit to me shamefacedly that their GPA during their freshman year was not everything they hoped it would be, and therefore they're worried that nobody will consider them for an MD-PhD program. So we look at applications holistically. We want to know everything about every aspect of the applicant, one of which is the GPA and how you challenge yourself and how you did at the end of college and not just how you did at the beginning. If your GPA as an undergraduate was not one that you are super proud to shout from the rooftops about, but then you did some graduate courses and did really well in those, we'll absolutely take that into account because we're looking at everything. And everything means a lot of information about you.
Right, that's awesome. Dr. Brass, do you have a few more minutes? I just remember that we have a lunch break after this, and you have a lot of questions still from the audience. So let me know if you want to pick a few more before you go.
I'm happy to take a few more, but I have to be on a different conference at 1 o'clock.
Okay, yes, we can just spend a few more minutes on this. Let's see. This is a more personal question. It says, can you talk more about your personal research and how you combine it with clinical practices?
Sure, but to avoid taking 6 hours to do that, I'll give you sort of the abstract version of it. When I was in graduate school, I became very interested in the biology of a cell in our blood that's very important for helping us to avoid bleeding to death every time we cut ourselves. And that's a blood cell called a platelet. And platelets are small anucleate cells that circulate in high numbers in the blood. And whenever you cut yourself and make a hole in a blood vessel, they rush to that site, pile up, and keep you from bleeding to death, or at least part of that process anyway. And I studied that process and some of the basic mechanisms of it as a graduate student when I was getting a PhD in biochemistry as an MD-PhD student. And while I was doing that, I started meeting people who were hematologists who took care of patients with platelet problems and bleeding and clotting problems and lots of other blood-related problems. And it became very interesting to me. And as I got to know those people, I thought, gee, what they did professionally looked really interesting. And eventually that's what moved me in the direction of becoming a hematologist myself. So I continue to do research on how platelets work, how blood clotting mechanisms work, how the vasculature protects itself from breaking down unnecessarily and inappropriately, and how the relationships among all those cells exists all the time because they're constantly chattering to each other and exchanging information. It turns out that there are a lot of patients out there who have problems in that particular world. And those are the kinds of patients that I like to take care of the most. I take care of other kinds of patients as well, but those are the ones that particularly appeal to me because their problems are strongly related to the research that I do, some of which is in mouse models and some of which is in people. So that's how I blend all of that together. When I talk to other physician scientists, and I ask them, you know, how did you make this whole doctor and scientist thing work? The theme that emerges over and over and over again is finding ways to make good cross connections between what they do their research on and the kinds of patients that they help to take care of and the problems that they're working on in the clinical space. Because then things blend together in a way that is unique and synergistic as opposed to just confusing. Does that help?
Yes, that's a great response. Thank you so much. Let's do our last question. And this applies to the training while you're completing an MD-PhD program. What does the research training constitute? Is it more related to what you're learning as a med student, or is it more focused on laboratory training and techniques?
Well, the answer partly depends upon what kind of the PhD, meaning what field you're doing the PhD in. Because as I said, at Penn's program, as with some of the others, we've got historians and economists and anthropologists and all sorts of things. But the answer, the broader aspect of your question, you know, really the purpose of going to graduate school is to learn how to think like a scientist, right? It's not to learn a particular skill that will, you know, be outmoded within a number of years. And it's not to answer a particular question that you're then going to spend the rest of your life working on. It's learning the skills of identifying interesting problems and how to address them and solve them. That's what graduate school is all about in the best sense of the word.
Great. Thank you so much, Dr. Brass. I think at this point, we're going to wrap up with our session, but thank you so much for joining us today. It was really an honor to have you, and a lot of students asked questions during the Q&A. So I'm really sure your presentation provided them with a lot of information that they will need to decide if this is the right career path for them. So thank you again.
Thank you, Alejandra, for organizing this for so many students and for you know, reaching out to me to help do this. Good luck with your own career path ahead and your own applications. And to everybody who's still listening to this call, keep up the good work and don't let anybody talk you out of doing something that you dream of doing, whether it's becoming an MD-PhD student or anything else. Best wishes and good luck to all of you.
Great.
Bye now.
Bye. So I guess it's time for our lunch break, everyone. We will be back in 1 hour. So yes.
And meanwhile, while you're during your break, if you want to stay on the call, we have a loop on presentation filled with plenty of announcements. So while you're munching or eating your lunch, you can breeze through them. I'll go ahead and share my screen now. We will see you at 2 o'clock. Have a good lunch.